Okay, so I wanted to put together a sort of overview video of what I'm currently working on, which is thinking or restructuring the way that I'm thinking about agents and the way that I'm also teaching or talking about agents. So this isn't going to be like a fully sort of edited and structured video. I just want to show you a little bit of what I'm thinking about and explain where I'm coming from, really. So all in all, this is part of actually a broader thing that I am working on, which is actually why I haven't been posting on YouTube specifically for quite a while now. I think it's almost 2 months, which is the longest I think I haven't posted in forever. And it's because I'm working on this, but it's also for other things as well. I had my first son like a month ago, so I've been pretty busy there and just working on a lot of things over at Aurelio as well. But I wanted to go through this introduction to AI agents article that I'm working on. And it's done, but I do want to put together a more structured video and some sort of course materials on this. There's even already a code example for this, which is just taking a look at the React agent, which is obviously one of the it's probably, I would say, like the foundational structure for what agents look like today. Or when I say agents, I mean LLM based agents. And I think, that is just the most popular type of agent. Okay, React, but now it's more like tools or tool agents, but they're very similar. But anyway, I want to talk a little bit about them. So the first thing I do want to maybe cover very quickly is the React agent, because that's what we're most familiar with. So I'll come down to here. So as a reminder, okay, React is basically this here. So we have some input, okay, some text. And rather than just asking our LLM to answer directly, we allow our LLM to go through multiple reasoning steps. And part of those reasoning steps is the fact that the agent can also call tools. So it can get some external information or do something else. And that's what I'm visualizing here, right? So we have our question. This is from the React paper, which I have linked to. But the example is, okay, aside from the Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? Probably, to be honest, most LLMs can answer this directly now, I think, particularly given that this example is from the React paper, which is like 2 years ago. But anyway, it's off topic. We're just giving an example here, right? So in this example, what we're doing is, okay, we have these tools that the LLM can use. We provide them. And we're also prompting the LLM, to say, okay, go through these multiple steps of reasoning and action. So that is where the React comes from. So it's RE and act from action. And it goes through these steps. So it's like, okay, I have access to the search tool and like an answer tool at the bottom here, which is not really a tool, but it kind of is at the same time. So it goes through, has this prompt, and it knows I have to structure things in this React methodology. So that's what it does. It says, okay, it starts. It says, okay, I need to search Apple Remote and find a program it's used for. And then it structures an action based on that. So it knows it has a search tool, and it knows that the input to the search tool is a query, which is a string. Okay, so we have the Apple Remote. That function runs using some logic that we've developed. And the observation from that is this. The Apple Remote is designed to control the front row media center. Okay, so what was the question? We have, aside from the Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? So now we know what that original program was, right, which is front row. And we have that information. The LLM now knows that information. So it goes on to a next step and it says, okay, what do I need to do now? I know that Apple Remote controls the front row program, but what other device controls the front row program? So it says, okay, based on this, my next reasoning step is I need to search front row and find other devices that control it. So then it does this search for front row. It could also probably do something, if we're thinking in RAG terms here, it could be like device to control front row, and probably a more up-to-date LLM would do that, but that's fine. This is just an example. So it goes back to the search tool again, and it says query front row. And this isn't like I've shortened this for the sake of brevity. I think in the actual example, it or at least from the paper, the actual example returns a lot more information. But this is the part of it that is important. All right, so front row is controlled by an Apple remote or keyboard function keys. Okay, so now we know that gets fed back into the LLM. So the LLM, now knows everything that we've covered here, knows the original query. And now it's like, okay, well, I have all the information that I need to answer the original query, which is, aside from Apple Remote, what other device can control front row? So the next step is the LLM is like, oh, okay, I have everything. I can now provide the answer of keyboard function keys to the user. Okay, and so it doesn't use a search tool. And now it instead uses the answer tool, which has this query, parameter out. And the answer or the output for that is keyboard function keys, which then gets provided back to the user. Okay, so this is the React agent, and this sort of structure of like reasoning, building a query for a tool, getting a response, and then potentially going through another iteration of reasoning and action and another, and then eventually providing an answer. That is really the sort of commonly accepted definition of what an agent is. That's what most people are using at the moment. And I think that is great, but I think it's very limiting because I just wouldn't, in production, I would never just put something like this, whether it's React or OpenAI tools or whatever else. I wouldn't just put that. In my opinion, an agent is much broader than just what this is. And also in general, broader literature, an agent is not just this either. So I went back and I just went through a few papers to try and figure out, okay, what is an actual good definition of an agent that kind of makes sense in the way that I also understand agents, the way that I've been building like agentic more workflows, to be honest, right? But to me, workflow or agent is kind of the same thing. It's agentic workflow, i.e. agent. So anyway, I went back, and the paper that I think had the nicest definition that tied back to really like original like AI, philosophy, like the original AI philosophy or the original AI research, maybe not original, but pretty close to original. And I would say maybe original, was this, right? So it was a Miracle paper, right? Which is another basically agent, LLM agent. I think this came just before the React agent paper. It's very similar. I would say it has a bit less structure than the React agent. But yeah, it's super relevant. And the way that they described their system was that it was a neuro-symbolic architecture, right? I really like this definition because a neuro-symbolic architecture, it's two things, right? You have the neuro part, you have the symbolic part. And I have another kind of starting on this article, but it's there's mostly notes at the moment. So the neural part of this, in fact, let's start with the symbolic part. The symbolic part is the more traditional AI, right? So I think this is back in the 40s, 50s, 60s, mostly, and then maybe 70s as well. This was actually maybe not 70s. This was the sort of traditional approach to AI, and the idea or the symbolists that were just like full on symbolists felt that true AGI would be achieved through written rules, ontologies, and these other logical functions. So basically a load of handwritten stuff, like smart, like philosophical grammars. An example of this is I think it's syllogistic logic from Aristotle. And so basically an example of this would be I think it's called, so you have this major premise, then you have a minor premise, and I haven't done this for a long time, so forgive me if I'm not super accurate. But you have a major premise, minor premise, and conclusion based on that. So the idea is, like, if you say something like, all dogs have 4 legs, which is maybe not actually true, but let's just assume that all dogs have 4 legs by nature. Okay. In fact, let's just remove that bit. Let's not be too pedantic. All dogs have 4 legs, right? That is your major premise. Then you would say, my friend Jax is a dog. Okay. Your conclusion would be, okay, my friend Jax has 4 legs. Okay. So this is a sort of logical framework developed by Aristotle. And the symbolic AI people would do things like these sort of exercises where they're going through all this and trying to build up some sort of logical methodology to allow you to kind of construct some deeper like AGI type system where it can just kind of figure everything out. Now, that was like one side of AI back then, and this is like the traditional AI. It's also called like good old-fashioned AI. I don't remember who or when that was termed, but GoFi. I don't know if they actually call it GoFi, but that's how it's written. And yeah, I mean that was one camp. The other camp were the connectionists, or this is what we called them back then. Now it's kind of the neural AI type thing. So connectionism was so kind of emerged back in 1943. There was this basically a paper that described a neural circuit, but really where neural or connectionist AI really started with this guy Rosenblatt, who introduced this idea of a perceptron. And it's actually the perceptron is in an adapted version of the perceptron that he described is what we use in neural networks today. So it was, okay, now it's a big deal. Back then, they were less useful, but a lot of people really believed in it, and they probably, at least so far, they were more correct, I would say. Now, the connectionist approach is focused on building AI systems loosely based on the mechanisms of our brains, right? So neural network, perceptron was just like a kind of silly name. Now we would say things like neurons within the neural network. They all have these sort of names, right? Where you can tell they're kind of coming from the idea of a brain. I don't have an example here, but you can see, okay, if we have a look at in Google, this is the perceptron, right? And then if you look at a sort of a neuron diagram, if that's a thing, activation, kind of, there's something, right? So here you have an actual neuron diagram, and you can see there's a lot of similarity. I think this one, they're probably comparing it to an actual neuron in the sort of AI sense. Actually, here is a perfect example. Let me make this bigger. No. right? So this is a good example. On the left, you have all these inputs basically for your neuron in your brain. It goes through some kind of calculation, which in this case is the axon. And then you have all these outputs. Okay, and this is actually many outputs, but you can think of them as kind of similar in some way, because all of these axons here, to be fair, I think they have different degrees of activation. But when you get your output here, you just have sort of one output. So I suppose in some degree this would be different. But just when you look at a single neural network neuron, obviously we put many of these in many layers, and then at that point you have many sort of axons, although each one is just coming from a single output here. But anyways, there is definitely a lot of similarity here. So yeah, anyway, that is one of the fundamental building blocks of Neuro AI. And yeah, for Neuro AI to work, you need a lot of compute, parallel processing, all this sort of stuff. And because of that, it didn't really kick off. And there was a few like AI, what we call AI winters, where people were just less interested in AI in general, but particularly the neural or connectionist AI. And yeah, I mean, that kind of carried on into the future until we got towards like 2011, 2012, where you had ImageNet and the what was it called? The AlexNet model. And they sort of kicked off interest in neural or connectionist AI again. And at that point, it's just like neural networks. Like everyone's just like, wow, neural networks are amazing. And we still think that that's what transformers and LLMs and their core building block is. Well, they are a type of neural network, just more kind of big and complicated. But anyway, so that kicked off because we had loads of data and compute and everything, and yeah, it led to where we are now, right? So that's what the neural part is, and that's also what the symbolic part is here, right? So, okay, what do we have here? We have both. We're mixing the like old traditional AI with neural AI. Well, kind of. To some degree, they are almost kind of mixed together already with neural networks, because neural networks, the way that they work, they almost learn symbols, like they learn logical representations of different concepts, which is what the symbol part is in some symbolic. They learn these, right? But they're just not handwritten. Okay, so neural network kind of learns what a strawberry is or what a dog is. But anyway, kind of beside the point. We can just assume, okay, maybe neural networks are sub-symbolic, but for now, let's just assume they're purely symbolic. That's fine. So neural networks make up the neural part of this. So basically LLMs. Then we have the symbolic part. The symbolic part, as I mentioned before, it's handwritten stuff, right? So like code. So if you write some code that can be run by or triggered by an LLM or some other type of neural network, that you have some sort of neuro-symbolic architecture. You have a mix of both. So that is what that is, right? And when they developed the Miracle system here, they were using, I think it's like GPT-2, no, maybe GPT-3, but like the first version of it, which was not that great. And then they were testing with, so this was actually their sort of agent system, but I think they built at least part of this on top of I'm not sure if it was open source model. I don't remember the name of it, to be honest, for the life of me, but anyway, it doesn't matter. So they basically built this agentic type thing by mixing neural networks with runnable code. Yeah, and then you actually see some of the things that they're talking about here are, kind of the things that we try and solve with RAG in many cases, lack of up-to-date knowledge, lack of proprietary knowledge, all these sort of things, which is kind of interesting, I think. But anyway, so my definition of agents kind of goes along those lines. It's neural plus symbolic. And the reason I like it is, one, we have that sort of that definition is anchored in, you know, the AI for the past almost 100 years, maybe 80 years roughly, which is great. I think it's good that we have some like really very solid foundations behind that definition, neuro-symbolic. And two, one of the reasons I like it is because when I'm building these systems, okay, LLMs are great, but I don't just use LLMs. A lot of the time, there is very good reason to bring in other neural network based models. So by broadening that neural definition to neural network, you don't restrict yourself to just saying LLM, right? Because, okay, use LLMs, like amazing, and of course I use them a lot, but not just LLMs, right? So the idea behind, if I go to semantic router, I don't know if you've used it, not a big deal if you haven't, but the idea behind semantic router, let me find an image instead. Actually, maybe I have an introduction here. Wow, we don't have an introduction. Okay, so this is a better example, or easy to explain example. So semantic router uses embedding models, which are neural network based. And what they do is you have some text. I have a better image somewhere. Let me find it. Okay, so this is the other example. So we have an embedding model, this thing in the middle here. And what we do is we provide some example inputs, right? So this like political route is just, this is more for like a guardrail, right? So this would be an actual guardrail here. You know, like protection basically. And okay, that's fine. Whatever. That is just one example. Then we have the Ask LLM route, and this is a better example. So the Ask LLM route, all right, so I'm saying, okay, what is the Llama 2 model? Llama 3 now, I wrote this a long time ago. Tell me about Meta's new LLM. What are the differences between Falcon and Llama, right? All of those are obviously things I want to trigger a search, right? So what I can do is I can identify this with the embedding model. So I can say, okay, anything that gets caught in this little area here, anything caught in that area there, that is probably the user asking for us to do a search, essentially. So then what we can do, what there's many things we can do, but one thing we can just do is say, okay, that's the user's query, just send it straight across to some RAG pipeline, right? So don't even ask the LLM, don't even ask an LLM to rephrase it or, you know, make a decision to use the RAG pipeline. Just use a RAG pipeline directly, and it's way faster than going through an LLM. And I would say probably much more controllable. However, LLMs provide a lot of flexibility, so that's not what I would usually do. Instead, what I usually do is there's still an LLM, right? So let's say over here, right, I have an LLM. And what I do is, okay, we have our query that we got from the user. What I'm going to do is I'm going to modify it a little bit. All right, so I'm going to come over here, and this is just like a kind of lazy way, but it works well, and it leaves the flexibility of use down to the LLM, which I like. So I say, okay, original query, right, from the user. So whatever that was. So we have the query, and then I append something extra. So I say, like system note is something I've used fairly often before. And I'll just say, use the RAG tool. Okay. I don't like this new. Maybe that is a nice fun. It's fine, whatever. I'm using this one now, right? So I modify the query that gets sent to the LLM. And in the LLM, you're basically kind of heavily suggesting to the LLM what it should do. And that works actually very well. So this sort of system the agent is not just the LLM, it's also the embedding here, right? And especially if you're not even including an LLM here, right? There's, like, to me, this system without an LLM is pretty agentic to me, right? That seems to me to be an agent. And then even more so when you add the LLM and decision making in there. So yeah, I prefer to think of agents as this type of system, right? Or not just this type of system, but at least more flexibly. Because I think that if you think of agents just as an LLM that can call tools, you're massively limiting, you're boxing yourself into this one thing that an agent may be. Whereas I think that's kind of a stupid thing to do. And even if you take the example of, okay, let's say we have multiple like tool sets, or we have, okay, once we've decided on one tool, okay, let's start here, right? Let's say we make a decision. Our LLM is making this decision. That's fine, no problem, right? But it goes down these two different paths, right? So it says tool A or tool B. And let's say if we have used tool A for, whatever that is, maybe it's reading about the news, whereas tool B is, it's someone's asking a math question, so it's like a calculator, or it's actually, maybe it's searching for some explanation from like a math website, right? Whereas this is going to a news website, right? Two different use cases, and what you might find with these two different use cases is that the follow-on tools, if any, right? Maybe there aren't any, who knows, right? But maybe there are, and the follow-on tools for these would be different, right? You've already identified that the intent is is two very different things. So why would the follow-on tools be similar? There's no reason for them to be. So in this case, right? So you may still have an LLM in the middle, maybe sometimes you won't, but you would then follow this slightly different path, right? And if you're thinking of agents as just, it's a LLM plus some tool calls in a loop, right? You already, this is fairly simple and you can't do it. So that's what I'm thinking about with agents, right? That's how I would approach them, which is slightly different to, I think, what the standard sort of narrative is from most people on what an agent is, right? Which is still, okay, it's valid, but it's not all that an agent is. So I'm going to leave it there. I don't want to go, there's a ton of stuff I can talk through. I'll restrict it to this one thing for now. I will cover this with more structure fairly soon, and I hopefully will ramble a little bit less. But at least I think with this, you should get an idea of where I'm coming from, and the hopefully sensible to some degree logic behind what I'm thinking here. But anyway, that's it. So thank you for watching. I will definitely try and make sure to release something else very soon. But for now, I'll leave it there. Thank you very much for watching. I'll see you in the next one. Bye.